sharing with you an emerging technology that we may soon see to be fully integrated in the construction industry. And I am pertaining to computer vision and how it can be utilized to achieve smart construction sites. As its namesake, computer and vision, this technology pertains to how computers can see things around them and interpret the things that they see. Much like us human beings, when we see things, we can identify what these things are. And imagine this ability being embedded also inside computers. With the computing power that they have, this technology just offers a lot of great potential for improving the day-to-day activities and operations of construction. By definition, computer vision is a field of artificial intelligence that trains computers to interpret and understand the visual world. Using digital images from cameras and videos and deep learning models, machines can accurately identify and classify objects and then react to what they see. Like I mentioned earlier, through computer vision, computers gain this ability to see things and understand what they are and to derive meaningful information about the things that they see. So how does computer vision actually comes to life? How does this work exactly? Well, like most of artificial intelligence-based technologies that we have today, computer vision also relies and banks on being trained or getting sufficient training to be able to recognize an image properly. This example shows that one model is trained to identify what a tomato looks like. So for training, we can show the computer various pictures of different fruits, different food, such as tomato, apple, and peaches, and we feed them into the computer and train them by telling them that this is what a tomato is supposed to look like, and this what an apple is supposed to look like, what a peach is supposed to look like. And then after several data fed into the computer and lengthy training, we can assess if the computer has gained the image recognition skills that we want it to have. So for us to be able to test that, we feed them, for example, a picture of a tomato, and if the model is indeed trained, or if it has indeed learned from the training, then it would be able to properly identify what a tomato is, and it can tell that that picture that you gave is actually a tomato. So this the fundamental of computer vision, and through this basic system of training, a lot of potential can be extracted from using computer vision. And I am certain that this is not the first time any of us has encountered computer vision in our daily lives. It's been around for a while and it's being used for different other purposes where image recognition is important, such as security, identifying individuals. For social media platforms, specifically, for example, Facebook, image recognition makes it possible for Facebook's algorithm to identify faces of people. So, for example, when you have a picture with your friends, sometimes you notice that Facebook automatically detects that that person on the picture is your friend or it's you, because Facebook has already learned what your face looks like or what your friend's face looks like. So in what ways can we actually export this technology to benefit the construction industry? Well, now some industry leaders are making a move to implement computer vision for site safety, monitoring PPE compliance, and using of virtual fences, tracking material and equipment utilization, quantifying worker productivity and flow, and measuring task or unit activity cycle. In the next few parts of this discussion, I'll be showing you some real applications of computer vision in construction. For this example, you can see by computer vision, we can define danger zones, and we can identify if workers are within those danger zones, if if there are fences present or not, and if there are safety hazards such as people under objects that are being lifted. Now, for this example, we can see that the computer can recognize the postures of workers, if they are placing, if they are compacting, if they are sitting. So this gives them, we can interpret the actions of the workers based on the information taken by the computer. And since the computer can identify the actions of that worker, we can see the movement of these people. If they are working, we can measure the productivity, the movements of these workers. And since the computer can also recognize the appearance of concrete, formwork, and rebar, it can also say if the concrete has been placed on this particular area, for example, if the formwork has been placed in this particular area, and if the rebars has been laid out as well. And just very recently, because of COVID-19, we had new regulations regarding social distancing, and this one model is able to identify if the workers are too close to each other or if they are following the 6 feet social distancing rules, which is very effective, especially at this around this time when we have the pandemic. This is where the model was used to identify if the equipment is being utilized or if the equipment is not being used. As you can see, it can see if the equipment is active or not active. Well, this gives us a lot of information on the utility of equipment, on how much we use a particular equipment at the end of an activity or at the end of a cycle. Similarly, we can identify the presence of workers in a specific area and if they are indeed wearing their personal protective equipment. For material mobility, we can also use it to identify the inflow and outflow of materials. Like this, you can see the dump trucks are identified by the computer to be coming in or going out of the site. By integrating computer vision, Indus AI, this one particular automation consultant, has already reported several benefits of using it. Some notable benefits are, of course, cost savings, we can see clearly, for project coordination, truck analytics, claims management, safety. There are also some intangible benefits, such as being able to capture tracking overcharges, capturing safety violations, and this gives us also a wealth of data because all of the videos, all of the images are recorded within the database that we can review throughout the duration of the project. But of course, implementing computer vision or automating construction sites does not come cheap. It means having to invest on high-speed machine vision cameras. One prominent supplier of these cameras is Cognex. We may also have to invest in a control center, deep learning, an additional deep learning system for additional image analysis if we want it to be more specific, especially for detecting materials or detecting very specific objects within the project. Or we can also enlist the help of a consultant, like they will integrate their technology in our construction site. They will come in to fully implement their technology, which means they have to cover everything. And to complement this technology, we also have to supply some additional materials such as barcodes and QRs and machine-readable patches and tags to go with the whole process. The challenges now that may hinder or delay the implementation of computer vision in construction, in the present construction industry, is one is being training the model, because again, for the model to be accurate, for it to be able to accurately recognize an image, it has to be trained as well. It has to have a lengthy training, and this exhausts a lot of resources and a lot of time. And for it to be beneficial, for computer vision to be truly beneficial, we may have to fully integrate it aside. I mean, if you use it only on a small portion of construction project, you may not see the whole, you may not gain the benefit you expect it to give. And again, this requires a costly investment, especially it's not yet on maturity. and very few projects are utilizing it. So it's still not being embraced fully by a lot of construction industry leaders. That's why it's still expensive. It would cost you around $200,000 or more. And of course, it depends on the size and the complexity of the project. To summarize what I have discussed, integrating computer vision in construction industry offers promising potential, improving safety, productivity, resource utilization, and workflow improvement. Computer vision is a sophisticated technology that necessitates considerable financial investment. So in order to maximize its potential, the use case of this technology must be weighed properly against the possible limitations and challenges that may be encountered in using it. And that ends my short discussion on computer vision and how we can achieve smart construction sites. Thank you for listening.